Everyone, I'll be doing question 9 from chapter 3, and it asks what is the name of this compound, so the IUPAC. Now let's start by identifying the largest carbon chain. 1, 2, 3, so that's a propyl, well since it's the main chain, propane. And then let's identify all of the functional groups. We have 2 alcohols or 2 hydroxides, so it would be dihydroxy. And then we have an aldehyde present. So because of the aldehyde, to show that there's an aldehyde present, we would scratch off the end and add an al to the name. Now when we're numbering this, we start from the terminal side that has the quickest, the soonest functional group present. So on this side we can see that it starts off with an aldehyde compared to this one, where the second one starts off with an alcohol. So we start from here. 1, 2, 3. So our naming for it so far, we don't need to label the al because it's on the terminal side. So we're gonna have so far 2, 3 dihydroxy, because that's telling us where the position of the hydroxides are. Propanol. Propanol. And now we want to identify, like, is this R or S? First, let's see if there's any chiral centers. Over here we can see that, sorry, not there. Over here we can see there's a chiral center because there's an O here, a H here, and a carbon connected to like a bunch of other things and another carbon connected to different things, right? So let's just draw this in like a more 3D version just so that our eyes can follow along. On the terminal side here we have a double O connected to an H, and let's say this left side is at the back, so there are hydrogens here, and then there's an alcohol at the front, OH, another hydrogen here, alcohol there, and then there's a H at the end. Now thankfully our weakest substituent is already in the back. So let's look at the strongest, the one with highest priority first, which is directly connected to this carbon, and it's the oxygen here. So this is 1, and now we already know hydrogen is the weakest, so we have to determine between this carbon here and this carbon here. Now this carbon here is connected to 2 O's, meanwhile this carbon here is connected to 1 O. So this one has the second highest priority, and then this one finally has the third. So going in that direction, since it's going clockwise, it's R, and there's only 1 chiral center. So our entire answer is R23 dihydroxypropanol, which is B. Now it can't be D because there's only 1 chiral center. Let's say if we went to 3, there's 2 H's, these are both equal, so can't be that. And it can't be either A nor C because of the direction of highest priority. Now the second question I have is question 12 from chapter 4, and it asks which compound is the strongest acid. Now it says propane. We know propane is very like nonpolar. It's very cool. It's very weak. It has a pKa of 43. Now the higher the pKa, the weaker the acid, and they want the strongest acid. So we have propane, we have water. Water already has a lower pKa than propane, so propane is out. We have ethane, which is also like nonpolar, it only has carbons and hydrogens. pKa is 25, which is higher than water, so that's out. Then we have benzoic acid. It literally has acid in the name. The pK is 4.2, which is lower than water. So that one is a lot more acidic. So it's the most acidic. And let's say you weren't given the pK values. We would look at the amount of polarity present. So the reason why water is a lot more acidic than the rest is because of the O there. That's being very electronegative, making the protons more accessible to be given away and donating. The purpose of an acid is to donate protons. So water is a lot more likely to donate its hydrogens away compared to propane and ethane because they're equally sharing their hydrogens. Meanwhile, benzoic has 2 oxygens, which is why it's more polar than water.